All right. Welcome everyone to the webinar Hands-On with Satellite IoT. I'm sitting here in the middle of nowhere. This is not a virtual background. I'm actually sitting somewhere outside because I'm going to do a live demo where I'm going to communicate with satellites directly. And for doing so, you have to sit outside. So before I start introducing all of the other speakers, I quickly want to run you through the program and explain you what we are going to cover today. The main objective is that you get all the information and all the tools to start building your own satellite-enabled connected solution. So we'll guide you through the whole process, giving you all the information, but it all ends with basically a device and connectivity that you can directly purchase from one of the partners here available today. So yeah, I'm really excited for this about NTN. That's basically what we call Satellite IoT, non-terrestrial networks. Starting off with introducing our speakers. Hiro, Senior Manager, Product Management at Murata. Hiro, you want to say a few words to introduce?
Yes. Hello, everyone. I'm Hiro Hidego, Senior Manager of Product Management in Connectivity Marketing in Murata IoT, in charge of global business. Thank you.
Perfect. Thanks so much for joining. Then we have Steven joining in from Skylo. Steven, you want to say a few words?
Sure. Good morning. So name's Steve Mitchell. I'm sales engineer for Skylo. And Skylo is, as you mentioned, NTN service provider, providing services for cellular services as well, like SMS, SOS, and IoT and automotive.
Okay, thank you. We'll hear a lot more from you later on in this webinar. And then we have Maor, co-founder and CTO of Monogoto. I think many of you already know him, but maybe you want to still say a few words about yourself, Maor.
Hi guys, nice to see familiar names in the attendees. Welcome to the non-familiar name. Looking forward to talk more about satellite and what we are doing here at Monogoto with our dear partners Skylo and Murata.
Perfect. Welcome. So my name is Lawrence. I'm responsible for developer relations and communication at Monogoto. I won't be doing a lot apart from hosting and doing the actual demo. So I don't really consider myself a satellite expert, but I did manage to get everything up and running just with relatively inexpensive hardware and maybe a couple of hours of my time. You should have similar, if not more, skills than I have. So the agenda, I will start with a very brief introduction about non-terrestrial networks and why it's relevant to look into it today. And then we dive more into the architecture. So we start at the low end, the hardware side, where Murata is going to guide us through. Then I'll hand over the mic to Steven, who will tell more about the satellites itself. And then Maor will talk more about the whole data routing and application development and how it all ties together. And then we come back to me where I try to give a live demo, sending data using Murata hardware over the Skylo satellites. Finally, we end with some Q&A. So there's a chat feature, Q&A feature, so feel free to use it and directly push all your questions there, and we try to address everything at the end of this session.
Once again, we have a guest here. I just see Pete joined. If you want to say hi, you're welcome, Pete.
Hi, everyone. I'm Pete Saldino. I run marketing for Skylo. I'm here alongside Stephen Mitchell. You guys have been amazing partners. Thank you to the team at Monogoto and also to Murata. You guys have also been amazing partners. I'm looking forward to speaking with you and introducing Skylo here today.
Correct. Thanks. Great having you here as well, Pete. So a very brief introduction about Satellite IoT. Well, as the name already implies, it allows us to directly communicate with satellites. And why you should care, why is it relevant now? Well, there's been quite a big transition in the last couple of years where the market moved from highly expensive devices and connections to very small scale, low cost and power optimized devices, which makes it suddenly applicable to be widely adopted globally. And as you will find out later on, there's the beauty that you can use a similar type of hardware, both for terrestrial networks or normal cell towers. And you can use the same chipset, the same hardware to directly communicate with these satellites. And we'll hear more about this, but one of the main features that I'm really excited about this is back in the days, you needed a hub. So a device needs to send a message to a specific hub or a gateway, and only that gateway could relay the message to a satellite. But as of now, this is not possible anymore. And with one of these very small, relatively low-cost devices that I'm having here, that I'm using this for this demo, I can directly communicate with satellites, relatively low cost and relatively inexpensive in terms of battery consumption. So that's my 2-minute introduction. And now let's let the real experts talk. So Hiro, the floor is yours. Feel free to guide us through your part of the presentation.
Hi, everyone. That is an electronics component company, and we are making a connectivity module as well. We are making a cellular module, NTN module, and also we are making other connectivity module as well, like 5G module. We are the module vendor for connectivity product. Please go to the next. I will talk about our, value of our module, NTN module, and I will tell you our module. Also, I will talk about something about the 3GPP specification for NTN and the major use case of the NTN. Please go to next. As I explained, NTN is satellite communication. Basically, this is a part of cellular specification, and it's a kind of coverage expansion of cellular network. And it's also good for the improvement of the network efficiency. If there's some huge traffic, like in some problem situation like disasters, NTN satellite communication can give you additional cost for the communication. NTN can give you the support for diverse use cases. Please go to next. Introduce Murata NTN module. Type 1SC NTN module. It's a dual function module of cellular communication, Cat M1 VLT, and also satellite communication, NTN. You can use both cellular communication and NTN communication just by this one module. If you are already using our Type 1SC module for cellular communication, you can add NTN feature by just replacing the module with this 1SC NTN module. You don't have to change any other hardware design to add NTN feature. Murata module is ultra small size module, 11.1 by 11.4 millimeter. Competitive module size is much bigger than this. Usually it's 16 by 18 or 18 by 20 millimeter. So the size is like a double, triple. So Murata module is ultra small size in the market. And the Murata module is fully certified by Skylo. Murata module is the first certified module, first certified dual function module of cellular feature and NTN feature. And many customers are evaluating our EVK with Monogoto SIM card and Skylo networks as a kind of lift price of NTN modules. And our module is seamless integration, easy, utilize NTN capabilities without any hardware design changes. And our module also supports integrated IGNSS feature. You need additional information to make a connection with satellite or NTN, but our module can support IGNSS feature to get position information without having external GNSS chipset. And our module is based on Sony RTL chipset. It's very power efficient, energy efficient, and it's very good for the battery life. Our module sample is already available, and it will be available through our distribution channel as well from June 2020. and you can get it from this chip easily after Gen. And we have many other values. Our module have many other values. Yes, small size, low power consumption, simple PCB design, and you can easily control our module by AT command. Really competitive pricing, slightly higher price than our CAPMR ABIT module, but compared to the usual satellite communication module, it's really low price. You can easily add satellite communication, almost same price with cellular and module price. Our module certified in FCC, ICA, we have a test report for RED, Europe certification, so easily to pass the certification as a product. And we verify the worldwide performance and the carrier certification. And we can also provide antenna line support. We have a global sales channel, and we have a really high quality. Let me talk about some major use case of NTN. There are two major use cases. One is pure like a quality expansion of the cellular network. You can have a data communication even outside of the cellular network. The second use case is data communication service even in some network trouble situation like a disaster or network down due to some network issue. NTN is basically sub-communication path. Cellular communication is the main path. If you don't have a cellular communication, you can extend the coverage by engine. Let's go to next. This is more detailed use case example. NTN is really good for tracker or monitoring devices, like a human tracker, container tracker, or livestock monitoring tracking, and vehicle, ships tracking monitoring, and agriculture monitoring. Another use case is a wearable device. It's good for sports watches or emergency call device, the wearable device for the like hiking in the mountain, woods, ocean. Those are the main good use case for MTN. Murata have some video for MTN. If you have time, please visit our website and please watch our MTN video as well. We will share the link later. So, yeah, that's it from Murata side. Thank you very much.
Okay, thank you very much, Hiro. So we will make sure to include the link in the follow-up email. So thanks so much. And it seems that there's already a ton of interest for your hardware if I look at the different types of applications that you're supporting. So Stephen, would you like to take it over?
Absolutely. All right. So go ahead.
Yes, we can hear you.
Yeah, go ahead. Next slide.
Sorry.
There we go. All right. So first of all, Skylo, founded back 2017 with expertise garnered from like MIT, Stanford, Google, Samsung, and the like, with presence headquartered here in Mountain View, California, presence in Finland, India for development purposes, and honestly, global coverage as a result of the satellite network that we operate. Next slide. And speaking of that network that we provide, it's really broken into three main components. There are the devices, like those provided by Murata for Monogoto. Those would be IoT types of devices. We also provide mobile chipsets for devices like Pixel phones, Samsung phones, and such, as well as automotive applications. So those would be the end devices. From there, traditional IoT or cellular applications would then go to a cellular network, whereas we make use of partnerships with satellite service providers. And those currently would be types of networks like geosynchronous orbits, which we'll talk about in a moment. But there are also the up and coming LEO options that we also are quite capable of making use of. And then the third piece of that would be the software element, which making sure that we can interact with these existing cellular networks and also emulating a lot of their functionality so that developers of applications that do reach IoT or mobile applications would have an experience that is similar, whether it's going over a cellular network or whether it's going over a non-terrestrial network, making sure that we can provide a similar service regardless of how that connection is provided. Okay, so next slide. There is a little bit of question about, the mechanics of non-terrestrial network. And there's LEO, MEO, and GEO. These are all types of orbits that are out there. And one thing that sort of struck me when I got familiar with it is the scale of it. So LEO, if you look at that little animation, those are very close to the Earth. They are actually so close, they are impacted by the atmosphere and have a limited lifespan as a result. Satellites in low Earth orbit maybe only last 5 years or so without some sort of rocket assist to get it back into that higher orbit. And then you go up into the medium Earth orbits, and those would be satellites like GPS, mainly like navigation types of satellites. And finally, the geostationary, those are interesting because the satellites there, once they are placed into orbit, they actually retain their relative position over the location on the Earth, right? So if you align your antenna once to that geostationary satellite, you're going to be able to retain that alignment regardless. Whereas the other types of satellites, you would need to have some means to track as those satellites move into and out of your field of view. Certainly, these are all and there's another big benefit to geostationary is the fact you can cover the entire globe with just 3 satellites. So with the satellite partners that we have, we certainly have more than 3 satellites on there, so we can provide full global connectivity with the non-terrestrial network. All right. So this map is actually showing, though we do have global reach, these are areas that we currently are already servicing customers. So you'll see North America, South America, Brazil, Europe, as well as Australia, New Zealand, with some progress over in Japan as well, which is work ongoing right now. One of the other questions that we periodically get asked is what spectrum and what throughput, latency, and things like that. So this slide actually lays out the spectrum that we make use of. So it's L-band or S-band. If you're looking for L-band connectivity, that's globally band 255. If you're looking for S-band connections, if you're in North America, that would be band 23. And in Europe, that would be 256. The connectivity method, like the packetization, what we're going to be demonstrating today would be IP with a UDP-based header. The data frequency, we're looking at about 20 packets per minute if we're making use of these geostationary satellites. As future technology comes online, keep in mind that the geostationary satellites have been up in operation for a good period of time. They're stable, they're known entities, and they are actively providing services. Some of the other technologies, the LEO-based solutions, those are ones that are currently getting deployed, and we certainly provide the option to migrate to those as they become more mature and become more available. 20 packets per minute. Each packet can be up to 1,200 bytes. And what we've observed is a latency of on par with between 5 to 10 seconds. That is in part the fact that it is farther. It's a round trip is about 75,000 kilometers there and back. That's about 1/4 of 1 second of flight time for those photons making that trip. And a lot of the rest of that has to do with modulation and repetition that you use to make sure you get a good quality signal when transmitting over that long of a distance. So that covers that. And that covers my section. If anyone's got questions, happy to field them during the Q&A.
All right. Thank you so much. 35,000 kilometers. It's crazy to get your head around that one of these very small devices that use a normal regular antenna can cover that whole distance in just this split second. Although there is latency, as you will see in a second, it doesn't feel very significant. It's really amazing technology. Moving forward, Maor, you want to continue with the next section of the presentation?
Yes, I will. Thank you for everyone. Thank you, Lawrence. Yeah, it is amazing. I remember the first time, I think, almost 2 years ago when we went to see the demo at Skylo before we signed the agreement, and both me and Itamar were amazed. So the more technical you are, the more amazed you are that this is with normal power consumption, normal antenna can communicate so far. So we at Monogoto, our job is to simplify the technology. We are a cloud connectivity service provider, and our job is to simplify the developer life when he needs to, for example, add satellite to a use case or do any other thing that required connectivity. So as a connectivity service provider, we added Skylo, I think almost 2 years ago, a year and a half, and now we start to see a big ramp up in NTN usage. But we added it not to a silo of let's just build a satellite network or a satellite offering. We added it to a connectivity cloud that is already global. And in the bigger picture, what makes people very interested in NTN is not the fact that NTN is capable, because we had the Iridium, we had other networks that are proprietary and provide the satellite. The ability with the same module that is sub $10 module when you scale, or on the area of $10. So with the same module, to be able to connect to the public network, to the terrestrial network, AT&T Mobile, worldwide, and with the same module to be able to connect to a satellite network, that's grounded. That's the big change. That's the big difference, because now you can have a single BOM and a hybrid approach. So of course, we are at Monogoto are enabling that. We are enabling that by us we are a global service provider. The use case that we love to demonstrate, and we did a live demonstration in the Mobile World Congress, is a device can connect to a private 4G in a place without reception or in a warehouse, then on a public connectivity on global operators. And the same device, the same BOM can also connect to a satellite when there is absolutely no coverage and a need to transmit. I will talk a little bit now about the constraint. I will talk a little bit now about what you get on each connectivity. But the most important things, Lawrence started by explaining that he don't know much about satellite, and still he is sitting in his garden and he's going to demo for you guys how satellite is being used for IoT. And thanks to companies like us that lower the barriers, the chip is easy to get, the connectivity is documented, all the barriers of making it work is being taken care by us. Instead of you as companies will be worried on which service provider should I talk to, where will I do my contract with, what technology to choose. We are lowering the barrier, we are taking care of the how, and then if any company wants to build a satellite use case or add satellite to an existing use case, can use us and worry less. Exactly like any other cloud company is doing it for other technologies. And I want to summarize some facts so we will all be aligned. I see some questions. Hopefully some of the questions I will also already answer now. But very important for us, we are a cellular provider. And as a cellular provider, we want to make sure that the module that the customer is using is the same. I don't like hybrid modules. I don't like modules that are doing just a single technology, because it's less interesting on scale and it's less interesting on the bigger picture. SIM card. Also the same SIM card. I don't need now to have a module with two SIM cards, one SIM card to connect to the satellite and another SIM card to connect to the terrestrial. Antenna. The antenna should stay the same. It's the L band, the S band is bands down on the 2 gigahertz. Maybe we have some constraint to see the satellites. The antenna should see the same. We are a service provider. Even the IP address stay the same. So think about a use case that you have an IoT device that is connected to AT&T, and then the IP address is X. When the same IoT device now don't have AT&T coverage, move to another area, maybe T-Mobile, still it will stay the same. And then when the same IoT device is needing satellites, we will not change the IP address. Everything will stay the same. So one service provider that can solve all these problems and still enjoy all the benefits of low power consumption. The experts are here to answer later, but satellite IoT maybe means that we can transmit less, but we don't need to consume more power when we transmit. Some important notes on satellites. Satellite is, at the moment, only doing UDP traffic. I asked ChatGPT to give me a UDP joke, but I'm not sure you will get it. Clear sky. What is clear sky? Clear sky means that still it's a satellite, so don't expect satellite to work out of a warehouse or indoor. Coverage. Coverage is important. As Skylo mentioned, geosatellites can be covering the whole world, but because of regulations, because of demand, this is still not available on the ocean. It's still not available worldwide. Be cautious and look at our coverage map before you want to deploy in some random country in East Africa, for example. Next slide. As a platform, we provide a single pane of glass with APIs. So one platform, you can manage the terrestrial connectivity. The same platform, you can manage the non-terrestrial connectivity, and you can decide for each use case if it will work on terrestrial, work on non-terrestrial, and you have a single place to manage your solution. Some important things that we added and we think are very relevant. We think, and we see it we have 100, I think, or more of demos and pilots and POCs. We have tens of customers that are actually live in NTN, and VPN is a great add-on. VPN is a great add-on because we said only UDP traffic. We said that it's take much longer to transmit, and we will talk about pricing in a second. It's also more expensive. So a VPN is allowing us to communicate with the IP address of the device, allowing us to remove the needs to add identity to the protocol, allowing us to remove the needs to communicate over NAT, and this is simplify and lower the transmissions that the devices needs to send when they send reports or receive reports. And that's a great add-on that is available in our platform. Before we go to the demo, we, as a transparent company, wanted also to give you some feel of the pricing. And that's what really exciting is that now we are commoditizing connectivity or democratizing connectivity or making it available for more use cases. So the idea of a cloud or consumption base is that now I can have a use case that will 80% of the time be on terrestrial network and will pay what we used to pay for cellular provider. And maybe on the 20% of the time or 10% of the time that I need an NTN, I will pay per kilobyte. So the price per kilobyte is more expensive, but we'll only use it when you just need it. Pricing is being calculated in chunks of 50 bytes. The first 50 bytes will be billed, and then whatever you're transmitting, typical payload can be up to 1,000 bytes. Very straightforward and very easy to consume and to add it to any use case. Do I have more slides? So now it's demo time, guys, and we will be happy to answer the questions in there. Thank you.
All right, thanks, Moor. It took me a minute to get your joke, but I get it. It's a nice one.
It took you a long time because of the satellite.
Okay, thanks. Let's go to the exciting part. Maybe the most exciting part, and fingers crossed that all goes well. Let me share my screen. If you give me 1 minute, let's see. Okay. first thing that I would like to say is I will walk you through the specific demo, but it might go somewhat fast. Don't worry at all because we've written down everything. So everything is in our documentation, docs.monogoto.io, and there are guides for all the specific development devices that we're using. And I am using this specific device, which is the Murata Type 1 SC device that Hero already talked about. So it's already available. We offer the dev kits, and what Hero mentioned, from June onwards, which is around the corner, it's available directly from different resellers. I can walk you quickly through this process. I already connected it to the satellites before the webinar because it sometimes takes a minute or so for the device to get a GPS fix. And from the GPS fix onward, it needs some time to connect to Skylo's satellites. And this usually takes a minute or so, what I have seen, but to avoid the risk, I already done so prior to this demo. So there are a few things you have to go through. And what you're seeing now are the AT commands that I sent from my laptop directly to the cellular modem. So I started with defining the communication protocol, so narrowband IoT. I set the APN settings to data.mono. And as Stephen already mentioned, you have to select a specific band. And as I'm based in Europe, I'm using band 256. Then there's some specific commands that relate to this module. So I need to use the IGNSS, which I at some point specifically enable. And this is important that the device gets a GPS fix because you need to know the exact location. And if you don't know the location, then it's not possible to connect to specific satellites. So for that, the location, the GPS location is essential. We can see here that I did retrieve a GPS fix. So if you look carefully, then you will find that I'm actually in the middle of Amsterdam, although the background might not suggest so. And from then onwards, I start enabling the radio, and then it took a few seconds to connect. And this is actually the number we're looking, or the feedback from the module that we're looking for, which is CREC is 5. And this is actually the same command or the same response as the module gives when it connects to a public network, because it means that it's roaming. And it was quite nice to see. So the feedback you get from the device is actually similar, whether it's on a public network or whether it's on satellite, because it's both roaming in that specific sense. So yeah, we're connected. And then the next step is sending data. So as Maor already mentioned, there are a few restrictions, which means that we can only send UDP data and we can only use narrowband IoT. So you need to have a UDP server to retrieve the data. And you can set up something yourself, but rather use something, or at least what I rather wanted to do is to find something that's already existing. So I found a platform that's called Ubidots, and that's an IoT platform that already has an embedded UDP server. So I set up a free developer account and I checked their documentation, and they claim that you need to send data in this specific format. I'll walk you through that in a little bit, but that's not too relevant now. Just walking you through the process. This is the IP address that I need to send to, and this is then the port that I need to use. Based on that information, I define the user agent as the IoT kit. I'm posting the message. Then this is the specific security token that I partly hidden. And then there's a device label, IoT device, and I'm faking some sensor data. So in my case, I'm saying it's 20.6 degrees because the device does not have embedded sensors. I'm just faking this one. And here's an important thing. You're not able to send text over satellites. So you need to convert that text to hexadecimal numbers. So I just found a website to do, which is called Rapid Tables. And once you select the specific text that you want to send, you can convert it to a string of bytes that you're sending. And this is the message that we're interested in to send. So it did so already, and it gives us this specific message that I want to send. So then, let's move to the device. And we need to fire a couple of AT commands. And the first one is that we need to open the UDP port. And then we need to activate that specific UDP port. And then there's the real test to send the UDP message. So as you can see, it's still fully empty as of now. And now I'm going to send this message. And the one thing I forgot to mention is that you need to count the exact number of bytes that you need to send. So in my case, that's 81. So that's far below the, 1,000 or 1,200 bytes and that you're able to send. So that's an important thing to add. You can do so by hand, but I just asked ChatGPT to count the number of bytes so I can provide this final message. So I'm sending this message, and as Steven mentioned, it might take 5 to 10 seconds before the message actually gets to the satellites and routes back to the ground station and forwards it to the UDP server from UBDOT. So let's see if it's there already. Doing one more refresh, and there we have it. So we can see that a new device appeared and it's seen a couple of seconds ago. Let's make it a little bit bigger. And then if we click on this, then we can find the temperature of 20.6 degrees popping up in this UDP server from UBDOT. Okay, in case you guys didn't fully believe what I just did, I'm gonna do it one more time with a slightly different variable. So now sending the data instead of 20.6 and now moving into 20.8 degrees, just faking data and showing how everything works in practice. And again, waiting for those 10 or so seconds before the message appears. And there you have it, 20.8 is the temperature. And then you can find further details on the platform. And that basically concludes the demo. So in a second, I will also show you the Monogoto platform, because it also, from there, you can find some device logs and device information that provides further information, knowing the status of the connection. So I'll be showing that in a second. And in the meantime, I find this fascinating that within a couple of seconds, with relatively low cost hardware, it can convert, it can send message and covering all that 70,000 kilometers. And that brings me actually to the first question that we only very briefly touched upon. And maybe Hiro, you can help me here explaining how it's possible that we can send a message covering that vast distance with just a normal antenna that you use on normal devices.
Yeah, we are using end-to-end communication. The module or chipset is using the NB-IoT modulation, same modulation with NB-IoT. This is really power efficient, and the radio loss in the aerospace is really small. And also, satellite have a huge antenna, so it can provide you a huge radio gain, antenna gain, using everything like a huge antenna on the satellite and the really power efficient modulation as an NB-IoT modulation. It can allow you to communicate between the device and satellite without changing the antenna line, without a huge antenna in the device. And can communicate with satellite by standard, etc.
Yeah, clear. Because I also saw a question popping up about the requirements of the antenna. And as far as I understand, there are no specific requirements, right? It's just a normal 4G antenna or a normal antenna that works for narrowband IoT that you can use for these types of technologies, correct?
Basically, yes, but kind of have some end product antenna performance requirement. So please work with Skylo to meet their certification requirement. But usually you can use standard single antenna.
Yeah. We have a list of devices on our website, skylo.tech/certified devices, which lists out all of the certified modules, chipsets, components, and then formal devices that have been certified. And you can get a real good sense of the fact that a standard antenna just should be fine. And we have a process for certifying those devices on our network.
Perfect. We'll make sure to include that list in the follow-up email. And in the meantime, I opened my Monogoto account and I would like to show you two things quickly. And the first thing is it's fully self-service, the Monogoto portal. And to get started, you can directly go to the Monogoto hub and order the Satellite IoT kit. So we offer it just for $100. And it means that within a couple of days, you can have access to all of those hardware. And that includes access to the Skylo network, as that's already embedded into the connectivity layer. And if I go to my personal account and then open up the device that we've used, then there are also some additional information that we can see. So you can see that now, as of today, some information has already been sent. So you can directly get the feedback from our network. And here you can also find all the detailed device logs to basically troubleshoot or define all the further information, retrieve all the further information. Great. So I see that there are a couple of more questions popping up. So let's have a look. So a question from Andrew. Does the device simply look for cellular connections, and if it's not available, it switches to NTN, or do I have to switch the mode manually? Maybe Maor, you want to maybe answer that question?
Yeah, so at the moment, AT commands switch to NTN. In the future, the module will be able to stay the same, and we can do setting of the SIM card to prefer or disprefer network. But at the moment, AT commands only, same SIM card, switch to NTN.
Okay, so that needs to be embedded into the application code. A question from Daniel: for static position, low power applications, is it possible to program a permanent GNSS position to remove the need for GPS fix?
Ryan,
Yeah, I'll take that one. Yeah, this is Ryan with Murata. So yes, you can tell it to use a permanent location. You enter that GNSS coordinates into the module, then you do not have to worry about doing a fix. And a lot of people ask about how accurate does my coordinates have to be. It's usually plus and minus 10 kilometers is more than accurate enough for the timing requirements of the module. So if the device is static, no need to enter it more than once.
Perfect, thanks. And I did see a question popping up in terms of pricing. So Maor already covered the pricing of the communication itself. But maybe a question to Ryan or Hero, maybe without giving exact numbers, how does a module that supports NTN, how does the pricing relate to a module that does not support this release 17?
Yeah, let me answer from my side. The price of NTN enabled module is slightly higher than standard module without NTN, but pretty similar price. Not so extremely high. You can add NTN feature with any minor price increase.
Okay, so we're still talking about a similar price range, whether using NTN or not. Okay, perfect. I think we have time for maybe one or two questions, and let's see.
if not, we will answer separately for whatever we don't have time.
Yeah, perfect. You can always reach out to us. We have also a forum where the whole support team is actively available. Let's see, maybe for Skylo, either Pete or Steven. I feel that there are a lot of startups, or see that a lot of startups are now appearing that specifically focus on those LEO satellites. And I think you mentioned that the GEO satellites, that the advantage is that you just need a couple of these satellites to cover the whole Earth. So why is there a need for LEO satellites, and what's then the advantage of the LEO over the GEO satellites?
Yeah, I'll answer that one. So thanks, Lawrence. As it relates to GEO versus LEO, as we showed earlier, we're live in 5 continents, 38 countries, and 60 million square kilometers of coverage. That provides a huge coverage area for all these new applications to begin. We are live because we are leveraging the existing geostationary satellites that are up in the sky right now. And so we're a software-defined network layer. And as new constellations are launched, we'll be able to connect to those. So I think if you understand us as a software connectivity layer, it's much easier to see this evolving as whatever new connectivity happens in the sky, we'll be able to connect to that as well.
Perfect. Thanks. Okay, I want to conclude the webinar. There's still a few very technical questions I see, but we're trying to get back to you later on by email, as I'd like to onboard the technical team as well. So for now, thanks so much for joining. Thanks so much for the speakers. And the beauty of this all is that you can try this out yourself as well. So $100, you get the dev kit, including everything to get started with Satellite IoT. So thank you so much for joining, and I'll be sending you further information and follow up by email later this week. Thank you.
Thank you, everybody.
Thank you.